Hello there! Why is it that in a party of mathematicians, beers are not allowed?
Why?
Because they don't drink and derive.
Enough with that. Today our topic is about integral calculus. I know you might be scratching your head now saying, I hate calculus. Well, that's a normal reaction. Thinking that with calculus, it's already the end of the world. But now's the time to erase those thoughts. For we are here to guide you and teach you. Call me Integral.
And me, I'm Anti-Derivani. We are your calculus tutor.
So, let's get started. Integrals. What is all about integrals?
To find out, let's start with the basics of integration. Have you ever seen this symbol before? This one here is the symbol for integration.
This time, let's have the notation. And yes, you might be thinking now, what are these letters? Let's find out.
F of x here is called the integrand.
Meanwhile, the differential dx is saying what variable are we going to integrate with respect to. In Riemann sums, dx refers to the width of rectangles.
Right, and finally, a and b are the boundaries.
Now, let's move on to the rules of integration.
First, we have the rules on bases and exponents, the power rule. In this rule, we have the letter n, which is the exponent. Integral of x raised to n dx will basically become x raised to n plus 1 over n plus 1. We will just add 1 to the exponent and the result becomes the next exponent in the denominator.
Let's try. What is the integral of x raised to 3 dx? So here, our n or the exponent is 3. This will become x raised to 3 plus 1 over 3 plus 1. dx, remember this, when integrated becomes plus c. The final answer is x raised to 4 over 4 plus c. Remember to remove the integration symbol when done.
How about the integral of the square root of x dx? Square root of x is equal to x raised to 1/2. Remember? Then now go on. Integral of the square root of x dx is just the same with the integral of x raised to 1/2 dx. And now, we can apply the power rule. This becomes x raised to 1/2 plus 1 over 1/2 plus 1 plus c. Simplifying, we get x raised to 3/2 over 3/2. To further simplify, we get the reciprocal of the denominator and then multiply it with the numerator, giving us the final answer, which is 2/3 of x raised to 3/2 plus c. That's it!
Now it's the time for the multiplication by constant rule. What is integral of 6x squared dx? So the constant here is 6. And the rule is, when a constant is multiplied, you can just move it outside of the integral and what's left to deal with are the remaining terms inside. So now, the integral of 6x squared dx is equal to 6 times the integral of x squared dx. Now, we can apply again the power rule. The exponent is 2, so we plus 1 equals 3. This now becomes 6x cubed over 3 plus c. Now, we can simplify it by dividing 6 by 3 and the answer is 2, giving us the final answer 2x cubed plus c.
Moving on, this time, let's have both the sum rule and the difference rule. What is the integral of x squared plus 3 dx?
Since the terms are added or separated by a plus sign, we can solve for their integrals separately.
First, with x squared, we apply the power rule. How about 3? When it's just a constant, we just add x, thus 3x. Note that we will only move out a constant when multiplied. Going on, x squared becomes x raised to 2 plus 1 over 2 plus 1 or x cubed over 3. We can now combine them. The final answer is x cubed over 3 plus 3x plus c.
How about the integral of 2x minus 4 dx? The process is just the same when subtracted. We solve for the integrals of the terms separately, 2x and 4. With 2x, we move out 2 and then apply the power rule. This becomes 2x raised to 1 plus 1 over 1 plus 1. And with 4, we just add x. Combining and simplifying, we get 2x squared over 2 minus 4x. The 2's can be cancelled, so the final answer is x squared minus 4x, and don't forget the plus c. Yeah, did you get it right?
That's all for today. Got it now?
We hope that you end up with a big smile now, and that you'll change your statement into I love calculus.
Remember, you just have to drop your hatred in math and start understanding and loving it.
We are your calculus tutors. This has been Integral.
I am Antay Derivani. Thank you. See you next time.